So I'm going to go ahead and finish up Chapter 9, one more concept that's covered in Chapter 9, that's empirical formulas, and we're also going to look at percent composition. So first thing we're going to look at is empirical formula. So the empirical formula is the simplest whole number ratio of the elements in a compound. The molecular formula shows the actual composition of the compound. So to find the molecular formula, the molar mass of the compound must be given. We're going to look at some problems in doing this. So here, what I have here is a molecular formula, C6H12O6. That's the actual composition of glucose. The empirical formula of that is the simplest whole number ratio. So simplest whole number ratio, all these are divisible by 6, so the simplest whole number ratio would be CH2O. So I can divide them all by 6. So here's some steps to find the empirical formula. A lot of times you're given the grams of each component. You have to convert that to moles using the molar mass. A lot of times you're given percentage. If you're given percentage, you assume you have 100 grams of the compound. That way you can just convert your percentage directly to grams. Then you're going to find your mole ratio by dividing by the smallest number of moles that you have. If a whole number is not found, multiply by an integer, usually 2 or 3 to get a whole number ratio. And this whole number ratio will give you the subscripts for your empirical formula. So here's an example. Given a compound that has 40% carbon, 6.7% hydrogen, 53.3% oxygen, find the empirical formula. Now I'm given the molecular weight to 180. What is the molecular formula? So first step, convert to moles. So 40% carbon, I'm going to assume 100 grams. So I'm going to say 40 grams of carbon. I'm going to round my atomic weights off to 4 significant figures. You can keep them all if you want to. You should still get the same answer. So get about 3.33 moles of carbon. Do the same thing as hydrogen. And the last one is oxygen. Now here, you have to find the mole ratio. So you divide through by the smallest number. Okay, so here's 1.0. 1.9956, so 2.0. So just go to 1 decimal place on these numbers. Then 1.0. Okay. So that's your empirical formula. So 1 carbon, 2 hydrogens, 1 oxygen. I'm going to look at my molar mass of that empirical formula. So I'll take 12.01 plus 2 times 1.08 plus 16. It's around 30, 30.03. So I know this is my molar mass of my empirical formula, CH2. I know my molecular formula has a molar mass of 180 grams per mole. Okay, so what times 30 would give me 180? So 30 times 6 would give me the 180. So that means all the subscripts I have here, I need to multiply by 6. So C6, H12O6. Would then be my molecular formula. So let's look at a different problem. Okay, so here this one says a compound is known to contain carbon and hydrogen. It might also contain oxygen. The compound is analyzed for carbon and hydrogen only, yielding the following mass percents: 54.33% carbon, 9.15% hydrogen. Given the molar mass, what are the empirical and molecular formulas? So it says it may also contain oxygen. How do we know if it contains oxygen or not? I look at my percentages and see if they add up to be 100. They do not add up to be 100, so I'm going to take the difference. And that'll give me my percent oxygen. So I'm going to do it the same way as the previous problem now. Convert my percentages to grams. Convert the numbers to moles then using the molar masses. And I'm just finding the number of moles here. Now I'm divide by the smallest number, so the smallest number is a 2.2825. That's what I see the most common mistake here is just using these numbers for your empirical formula without finding the mole ratio. So you have to make sure you find the mole ratio at this step. So 4.5237 divided by 2.2825. So 1.98, so 2.0. So 9.0774 divided by 2.2825 is 3.976, so 4.0. So my empirical formula is C2H4O. If I find the molar mass of that, so 2 times 12.01 plus, say 4 plus 16, it's around 44.02. I'll probably get it a little bit closer to that. So 44.052. So 44.052. Now my molecular formula, I'm given it has a molar mass of 88.106. So I have 44.05. What do I need to multiply it by to get 88.106? So I need to multiply it by 2. So that means multiply each of these subscripts here by 2. So my molecular formula is C4H8O2. So that's how you find some empirical formulas given the percentage of a compound. Now, percent composition is actually a little bit easier. You're going to just find the molar mass like we usually do, but write down each step. It's a little bit easier that way. Then you're just going to determine the mass contributed by each element. Then you can check work by seeing if they add up to be 100. So let's go ahead and look at a problem here. So I'm given this percent of mass of each element in TNT. I'm given the formula C7H5N3O6. So C7, so I'm going to write down carbon, 7 times 12.011 moles. Hydrogen, 5 times 0.1108. Okay, so just finding the molar mass here. Nitrogen, 3 times 14 is 0.02. And 14.01. And then oxygen is 6 times 16. So this time, instead of just totaling them all, I'm going to write out individually what each one of those steps are. So 7 times 12.01, 84.07, 5 times 1.08, 5.04, 3 times 14.01, 42.03, and 6 times 16 is 96. Now if I add all those up, just finding the molar mass, I get a 227.14. So now what we're going to do the percent composition is find the mass contributed by each element, which I basically did when I found the molar mass. So now I'm going to look at the mass contributed by carbon divided by the total times 100. And so if you was asked, like what's the percent carbon of this compound, you just have to do the first one, but I'm doing all of them. So let's multiply each one of those by 100. Let's get 37% carbon. .2% hydrogen. 18.5% nitrogen. And 42.3% oxygen. Then I can check my work, make sure they all add up to be 100, and it does. So that's how you do the percent composition. So that's it for these problems on empirical formula and percent composition. Bye.